Hello, good afternoon to everybody. Hope all of you managed to do your assignments. I uploaded the solutions in the app, and I hope all of you have seen that and verified the solution with the assignment, with the solution. Just one thing in the last lecture, I think for last couple of minutes there was some internet connectivity issue from my side. So because of that, I think last couple of minutes was not recorded. So let me just explain what I was doing in the last couple of minutes. So actually, the content I had finished. Only thing I wanted to tell you is that once you finish any worksheet, then how to save that worksheet in various formats. So let me open my last lecture worksheet. So this is the last lecture worksheet, as you can recognize. All of you, I sent this worksheet to all of you. So in case you want to save this in various formats, so you can just go to File, and in that case, you see there is one option called Download As, and that provides you various options in which you can download. So for example, you can download in PDF format. It is saved via LaTeX, so of course you need LaTeX installed in your system, or you can save it in HTML format. HTML format will not require tech installation, so you can possibly save in that format and open from anywhere. Of course, it also provides you in various other options. So this is what I was explaining in the last session. Okay, so let me come to the today's content. So today I'm going to look at basically three things. So first, briefly, I will explain three types of data which are in the form of lists, tuples, and dictionaries. And then we will look at how to plot various 2D graphs in various formats, and also plot 3D graphs. So this is what we would like to cover today. So let us see how far we can uh, proceed. Okay, so let us first look at how we can create a list. So in the last lecture, we have already come across some examples of list. But let us see. Suppose we want to define a list. Let me define a list of, let us say, countries, and this list of countries are, let us say, USA, Brazil, Russia, Spain, UK, Italy, and so on. These are actually first 10 countries having the maximum number of COVID-19 positive cases. Okay, so you can see here the way to create a list is you have to put this thing in a square bracket, and you have to be separated by comma. And you can see here these countries name are in text. So you can put inside single quote or double quote. Single quote and double quote both are same. Okay, so let me execute this. So this is the countries. Okay, now the various things that you can do to this data list data. So for example, you can ask what is the length of this list. Of course, in this case we would know what is the length, because we have manually entered. But in case you have some large list and you want to count how many entries are there in list, then you can use command called length. So let me say length and countries. So it says that there are 11 entries in this. There are 11 countries in this list. Okay. Now suppose you want to uh, extract some member of this list. So here this list is indexed by integers, so starting from 0. So if I say, for example, countries 0, it will give me first entry in the list, so that is USA. If I say uh, countries, let us say 10, it will give me let us say it gives me the last entry, right? Iran is the last entry in that list, last member of this list. So that is, so index starts from 0, so 0 to 10 is 11. That is why you see countries 10 is last one, which is Iran. You can also have negative index. So if I say countries, and let us say, for example, if I say -1, then it will give you the last entries. So -1 starts from the end side. So it is the, if I say -2, instead of -1, if I say -2, you can see it will be the second last, which is India. Okay, so this is how you can take a particular, and you can extract any particular entries from a list from this data. And there are various things that it allows you. So for example, let me define one more list, then we will look at some more concepts in this. So let me also define. So for example, let us say this is uh, list of COVID cases in each of these countries. So this is actually just yesterday's data. So it is, I'll simply say, I'll comment the as on May 24th, 2020. Okay, so this is, again, this is, so here in all these things, all these entries are numbers. So again, you can count how many entries are there. So how many the COVID length of COVID cases, here also there are 11, right? So for example, if I want to look at, let us say, so COVID cases, and if you say dot and press tab, then you will see whole lot of options or methods that you can apply on this list, right? So for example, it has append, it has something like clear or count, extend, index, insert, pop, remove, reverse. All such things are there in this. When I apply COVID dot tab, you will get all these options. So you can try to explore one by one. I will not get into each and every options or methods that you can apply on this, but you can go, you can explore one by one and see what it does. Okay, so let us see, for example, if I want to find out sum of the COVID cases in all these 11 countries. So I can just say sum, and you can see here it is 39,59,711. You can find mean, you can find various things, etc. So and various other things you can apply on this. So for example, you can even say, let us say, bar underscore plot. I think bar chart. And if I say, let us say, bar chart of COVID cases, you will get the bar plot of these things, right? And so you can just explore what other things. You can even create a table. You can create a table. So let me just look at this. So let us say, I'll say table of let us say countries and the COVID cases. So you can see here it will print this in tabular form. Of course, the table also has various options. You can put the separating columns, etc., rows, etc., also. But this is quickly you can right. So now suppose, let us say, I want to add one country in this list. So there is an option called append. So let us see, suppose I say countries dot append, and let me add one countries. Let us say, I think the next country in the COVID list I found, it is Peru. And let us also add the same, some number of cases in this country. So I'll say COVID, and then again append, and then I think the number of cases there is almost about 120,000. So let us just put 120,000. Now if I ask to find the table, this when we say append, it always appends at the end. You, of course, you have an option to insert in between also. So these things you can now if I say table COVID list, you can see here now this is at the end the Peru is added with number of cases. Okay, now there is another data type which is called tuples. This is called tuples. So let me say what tuples. Okay, so list is again a data type. One more thing, let me just tell you here. Suppose I wanted to change, let us say suppose I made a mistake and this last entry in this, so you can see here this this is going to be COVID 11 is the Peru entry. Suppose I want to change this, I made a mistake in entering this and in fact it was not 120,000 but it is, let us say, 121,000, right? So in that case you can see here now if I say table countries, you can see that the last, oh, I think it got appended once more, so that's the problem. Yeah, so it is I should let me run once again. So this and append Peru, this I will not run now. So in that case, right, this this one, let me run this again because yeah, this one, this is not needed. So number of COVID cases, right, these are fine. This is again fine. We have appended one Peru and the COVID cases. Again, I need to append that first. I need to append that. Append, let us say 1,20,000, and then we will change that entry. So what we want to change? We want to change COVID cases. The 11th entry, it was 100. We will make it 121,000. Right. So now if I make a table, you can see here the Peru case has changed to instead of 1,20,000, it has become 1,21,000. So any entry of a list can be reassigned, can be changed. There is another data type called tuples. So list entries we wrote inside a square bracket. Tuple entries are written inside round bracket, and they are nature wise they are very similar to each other. I'll tell you there is some difference between tuple and list. So let me write a tuple. So let us say I'll make a tuple of let us say number of deaths in these countries. So this is, again, you can see here the entries are written inside round bracket. Okay, so so there is a difference between list and tuple. Many I mean in mathematics, especially in linear algebra, etc., we keep using vectors, and vectors generally we write inside round brackets, right? So you will see that when we do linear algebra, the vectors will be given in this form. Okay, so but for bracket here, I think the again you can ask for what is the length of for example deaths. You can ask, you can extract any entries, let us say deaths, which entries, let us say -1 if I say this is the last one, and this if I say deaths, let us say 5, that is 6th countries death. So this is this one. Okay, right. So but suppose I want to change death, the number of deaths in the 6th country. 6th country is which one is Italy. So there the number of deaths is 32,784. Suppose I want to make a change. So instead of this, let us say I'll say that this is wrong. It was only 31,758, and then let us see what it can do. So it is giving you an error. right? It is giving you an error. So that means it is not, tuple is not allowing you to change the entries. Okay, so what does it say? Tuple object does not support assignment. You cannot assign any entry, right? So that is what the tuples are called immutable data, whereas list is immutable data. So that is one small difference. There are other differences, etc. We'll not get into the details. Okay, so this is one difference between list and tuple. So far we have used the square bracket, we have used round bracket. So round bracket, use of round brackets you have seen in two forms. One just now we saw using in creating tuple, and then we saw that we give an argument of any function inside round bracket. Now there is also a notion of giving data in curly bracket, and that is called dictionaries. That is called dictionary. So let me define a dictionary. Sorry. So dictionary is defined by giving entries in curly braces. Let me define uh, a dictionary. Yeah. So let us say this is a, let me define this is a dictionary. So you can see how the entries are defined. So here we are saying you start, the name of the dictionary is corona underscore dict, and then the entries are given inside curly braces, and the first entry is USA. Inside this is a text, so I put this in single quote. You can put it in double quote also, and colon, and then the number of positive cases, and then comma, and the second entry is Brazil, and then colon this. So this first entry here, these things are called keys, and these are called values. So when we define a list, then each entry is indexed by integer starting from 0. But especially when you have a large data set, then you cannot hope to access every entry by its index. Many times you would like to get information from its properties and things like that. So in that case, this dictionary becomes very important, especially when you want to deal with text data, etc. Data having in dictionary form is very helpful. Okay, so that is how we can. So you can see what are the values here. So corona and dictionary, and if I say dot tab, I then press enter, again you will see that various options it appears, like clear dictionary, copy, get items, keys, pop items, etc. And you can effectively, you can do, I mean, everything with this dictionary. So let us see, for example, I want to see what are the keys. So keys, these are the keys. It is giving in a list form. So USA, Brazil, Russia, Spain, etc. These are the keys. And similarly, you can ask for the values. So corona, corona, sorry, corona dictionary dot values will give you the values of each key, right? And you can also insert extra key along with the value. You can delete, you can do all sorts of things. So you can take you can apply let us say dot tab on corona dict, and then see what are the other options you can explore. Okay, so let me just see how will you add one extra data in this. So we already had one data in the in the earlier case. We added Peru. So let us say whether we can do in this case also. So we'll say corona dict, and you mention the dictionary name inside square bracket. So we'll say Peru, and what is the value here? The value here is let us say 1,20,000, 1,20,000. Okay, so now if I ask for corona dictionary, then you will see here the Peru appears at the end. Of course, in this case, the the way the list will appear may be slightly different from the way you have entered. I mean, especially the ordering, because it may have its own ordering, etc. So all these things you can explore. This is a very useful data type in Python, and hence in Sage. Okay, now let us look at where we can make use of this in mathematics to begin with, whatever we have learned so far. So if you remember, last in one of the problem in the assignment was to find to solve two equations, non-linear equations, and then find the solutions. And most of you have solved that problem. And so let us see, suppose we have two let us say we have two variables x and y. So declare these variables like this, right? X does not require declaration, but any other variable other than x will require declaring the variable. So let us say this is how we have declared. Now you have two equations. Let us say there's something, you have two equations. Let us say one equation is equation 1, which is x square plus y square equal to 1. Here notice that here I have put double equal to, and second equation is equation 2, which is x into y is 1 by 4. So this is a circle, unit circle, and xy equal to 4 is rectangular hyperbola. So we want to look at what what are the points of intersection of these two curves, so that you get using solve command. So you can say solve in the square bracket, give the list of equations, right? So equation 1, equation 2, and what is the variable for which you want to solve, that is x comma y, and you can put an option solution dict is equal to true. Solution, so this means that the solution should be in the form of dictionary. Now let us see how the solution looks like. Let me solve this, and yeah, so you can see here, this is how the solution looks like. This is a list of dictionary, and first entries in this list is a dictionary in with keys x and y. So x value, y value. So you can see here there are 4 solutions, and that is what you can expect. The rectangular hyperbola x into y equal to 1 by 4 intersects this circle x square plus y square equal to 1 at 4 points, and these are the solutions. Now the use of this is that, I mean, if I want to make use of this solution, it becomes very easy. So how do I access the solution? For example, if I want to look at the second solution, so this is the second solution. So remember, the solution is given in the as a list. So second solution in the list I can access as SOL and index 1. That is the second solution. That is what you can see here, right? The second solution is this, right? So it says that it is a dictionary, x value is this and y value is this. So let us say if I want to find out x value of this, I will say this square bracket x, that is the x value. Similarly, if I want y value, what we will say SOL 1 and then take y values. So these are the x values and y value. Only the last one is printed here. If I want to print both, I will put it in this comma, right? So this will print as a tuple. Okay. So let us see, for example, if I want to, let us say, store this in a comma b. So let us say a comma b is a solution, a comma b, tuple a comma b. You can put as a tuple, or you can simply say a comma b is a solution. And suppose if I want to substitute, so equation 1, and let us say I can say subs, that is substitute x is equal to a and y equal to b. Then you can see, of course, it has substituted. And is it equal to 1? So one has to I think simplify. So let me say simplify. Okay, so yeah, let me just, one can simplify. Yeah, so you can see here this product will be 1 by 4. So so that is how you can make use of the solutions. You can very easily extract the solutions. Many times when we are working with solution set, it becomes very important to extract these solutions so that you can make use of this. So that is where this dictionary is very useful. Okay, so so we have seen how to define a list using square bracket, and then tuple using round bracket. There is a difference between square, list, and tuple, and then how we can define a dictionary, right? So now we have made use of all the 3 brackets: round bracket, square bracket, and curly braces. Okay, so and each the 2 brackets, any 2 brackets, they are different, so we should not be mixing. Okay, so each bracket has got different meaning, so you should not mix them. Okay, now let us look at how to plot graphs in various format. Okay, so first let us so suppose you have a function, um, say fx is equal to x into sine 1 by x, and you want to plot graph of this function. So the plotting graphs in 2-dimensional or 3-dimensional can be done in various format. SageMath provides extensive, let us say, plotting facilities to plot graphs, right? So you can plot in graph of function which is explicitly defined, graph of function which is defined by parameters, parametric plot. You can do polar plot defined in polar coordinates. You can plot lines, plot points, point arrows. You can insert text and various other things. Similarly, in case of 2-dimension, sorry, 3-dimension, you can plot graph of 3-dimensional functions. You can plot level curves. You can plot contours. You can plot gradient, and you can also plot graph of function which is implicitly defined or defined by parameters, defined in spherical coordinate, defined in polar coordinates. I mean, you just name it, almost everything, standard things are there in Sage. So you can very easily plot things with in Sage, and you will see that the plotting is extremely simple. Okay, so let us first define this function fx is equal to x into sine 1 by x, and we want to plot graph of this function. So the simplest way of plotting this graph is that you can say f dot plot, f dot, and if you put dot tab, you will say option plot, f dot plot. Sorry, I have not executed this fx. So f dot plot, this is how it looks like, right? This is the graph. Now you can see here how uh, I have not given the domain in which it should plot, but by default it has taken domain from -1 to 1. By default it has put the graph color as blue and things like that. So there are some default options which will work, right? So if I want, let us say the for example, I want to see this graph very close to 0, in the neighborhood close to 0. I can say plot this from, let us say, point 1 to, let us say, from minus point 1 to point 1. Okay, now let us see. Oh, this looks beautiful. So this is a very simple way of plotting graph. So you can always use f dot plot. Of course, I'm not sure whether you are seeing the blue color as I'm seeing in my laptop. When it on the stream, it may be some different color. I'm not very sure. I think I noticed last time, but in any case, so this is right. Okay, so but you can also plot a graph in using a plot function. So let me say plot, and then we'll say f, and then we can mention, I can say, let us say x going from minus point 1 to point 1. Okay, so this is another way of plotting graph. Okay, and this graph, you can do various things to this graph. I mean, you can do all sorts of decoration to this graph. You can change the color, you can change the thickness, you can add title to it, you can change color of axis, the tick marks that you see on x-axis and y-axis, that can be changed, that can be put in various format, maybe especially if you are plotting graph of a function defined of a, let us say, trigonometrical function. Maybe you want x-axis to be, the ticks to be written in terms of pi, etc. All such options are available. So I'll just tell you few options, but other options you can see for yourself. You can just take help on plot. All of you know how to take help now. So you can simply say plot and then question mark and or double question mark. So it will give you help document. So you can go through this. I'll just make it bigger. So you can go through this and then see how you can make use of this document and how you can change various options. Or you can also go to SageMath site. You can go to SageMath site. You can go to documentation, and in this documentation, if you go to this PDF, there are so many documentations it provides, and one of them is, let us say, plotting. So if you click on plotting, it opens a I don't know how many, some 458 pages of document and describing all sorts of functions that it has. Okay, so this is how you can also go through this and explore various things regarding plotting. Okay, so let me go back to my Sage worksheet. Right. So let us see some options we want to explore. So for example, if I want to change the color, if I want to change the color, first let me change, let us say, figure size. So I can say plot, again the same thing, plot. Let me just copy paste the previous one. I don't want to keep on writing. So plot this, and at the end you say fig size. Fig size. Fig size stands for figure size. So let me say give an option, let us say 4 inches. So already default it has some length and width of the figure. But if I say 4, then you can see here the figure size has reduced. Okay, the figure size has reduced. Suppose I want to change, let us say, color, then you can mention, for example, I'll say one option, color, color is equal to, let us make it let us say green color. Okay, so you have to write this option green in a single quote or double quote. So let us see. Okay, so you can see here the color of the graph has become green. Again, I'm not sure whether you are able to see the the green color, or you are able to see only some other color. Okay, so but when I share this worksheet, it will be clear. Okay, so this is how you can change the color. You can also change, let us say, the plotting style. You can make it dotted line, or you can increase the thickness of the line. You can add grid lines. All such options are available. I mean, I would not get into all these options. So for example, if I say grid lines is equal to true, then you see that grid lines has appeared, and these grid lines again you can make finer, and all such options are available. So I request all of you to go through this help manual, and then see how you can explore the other options of the plot. So let me just um, do one or two more so that you can. So for example, if I say thickness by default thickness is 1, so I'll say thickness is 2, and let me say some other options. So for example, I say line style, and let us say put line style inside double quote or single quote, hyphen hyphen. So this will be dotted line, and let us say what else. Let me another say typeset is equal to, inside single quote, LaTeX, and let me also put title is equal to, let us say, I'll simply say graph of, let us say, x sine x into sine 1 by x. Okay, let us see how it looks like. Okay, something went wrong. Let me see what is the problem. At the end it will tell you line type set is not valid. Okay, a spelling mistake. So spelling mistake, type is missing. Okay, now you can see here. So you can see here the title has appeared, the color is remains the same, that the thickness has increased, the line has become dotted, and typeset, you, I don't know whether you noticed, if you notice the tick font and the font in this one, they are different. These are the LaTeX typeset the fonts, so it looks much better, especially in print. Okay, so these are how you can add various options, etc. Now let me tell you some more things that you can do. So for example, suppose you want to plot graph of, let us say, more than one function. Okay, let us say you want to plot graph of more than one functions. How do we do that? So let me take the first so what we can do is, there are multiple ways of doing. So let us say I have graph of f of x, and then let me call this as p, store this plot in p, and then let us say I want to add, let us say line y equal to x and y equal to minus x to this graph. So what we will do, let me say call as a p1 is equal to plot, let us say x, and that also varies between, let us say, minus 0.1 to 0.1, and let us say color of this color is, let us say, red, and uh, okay, and similarly p2 is this is plot minus x, and this color, let me make it black, let me make this as black. And then how do I see this? So you can simply say p plus p1 plus p2, you are adding p1 p2 to p, and then let me see what it gives. Yeah, so it has added two lines, one is y equal to x, this is in red, and black is y equal to minus x. You can see here this curve is enclosed between these two lines. Okay, so beautifully it has kind of plotted very easily. And of course you can give various options. In this case you can put the legend, so it will show you which graph is which and all that, etc. So if I, for example, if I say uh, legend label is equal to, let us say, I'll simply say this is f, in this case legend label, this is, let us say, x, and in this case legend label, this is, let us say, minus x. Okay, so something went wrong. Legend label, that seems to be correct. Yeah, okay, let me see. Okay, options, legend, oh, legend, the spelling mistake. Legend, last one. Yeah. Right, so you can see here the legend has appeared. Green is minus f x. Of course, this position of this legend also you can change. Okay, so this is how you can plot several graphs together. There are other ways of doing this also. We'll see it little later. Okay, now suppose, let us say I want to plot graph of, let us say, piecewise defined function. This is, so one piecewise defined function you can think of is a floor function, right? So floor function. So suppose I want to plot graph of floor function. So let us say we'll say plot, and then say the inbuilt function called floor of x, and let us say we want to plot from -5 to 5. Okay, so this is how the floor function looks like, right? Right, so between 0 and 1 the floor value is 0, between 1 and 2 floor value is 1, and so on. So these vertical lines also plotted along with this. So but this is not a, this is a floor function is a graph, is a function. So graph should not have anything vertical, right? So actually this is plotting should not appear this vertical line. Suppose you want to get rid of this plotting, this vertical lines that connects at the point of discontinuity, then also there is an option. So let me call this as f1 is equal to this, and let us say f2, sorry, this, and f2 is equal to the same thing. You have to use option, you need to use option that is let me see what I think, exclude, sorry, exclude. So what are the value you want to exclude? So for example, I want to exclude all these integer points starting from -4. So let us say -4 to 5. Let us say I want to exclude this. Now if I ask it to plot f2, you can see here now the vertical lines which were connecting are missing. That is not. You can even plot. You can plot f1 plus f2, or if you want to insert inside this graph at somewhere some other graph, that facility is also there. So if I say, for example, f2 dot, I think this function is called insert, and we want to insert, let us say f1, and at some position, let us say we want to insert in let us say the second quadrant. So then you can use various options. So let us say 0.2, you have to mention what is the position. So 0.2, then 0.7, and then let me say 0.2 comma 0.2. Mostly this is in a scaling format. No, I have to say position equal to position, POS equal to, I suppose, just 1 second. Yeah, POS equal to, I have to say equal to, in the bracket I should write. Okay, yeah. So you have see that it has inserted. So this 0.2 is actually with respect to this length and this height. Okay, and this is the size of the figure. Okay, so this is how you can insert. This is how you can insert a sub figure inside a figure. Okay, right. Now let us look at how we can plot, let us say, a graph of implicit functions. So let us look at this. Suppose I want to plot graph of a function or curve defined by x power n plus y to the power n for various values of n. So how do I do that? So you can say, let us say var, we need to declare x and y variable, though we have already declared, but it is still a good idea to still declare, because sometimes you might have used that to store some values. And then we'll say there is a function called implicit plot, and inside this, so let me say, I'll say n, to begin with n is equal to 2. This we already know how the graph looks like. And plot, implicit plot, we need to declare the function. So let us say f of x comma y, this is equal to x to the power n minus y to the power n minus 1. So I should declare n first and then f. Okay, and then implicit plot f, and let us say x goes from -2 to 2, and let us say y also goes from -2 to 2, and let us say put color is equal to let us say green. Yeah, so you can see here this is I have put x square minus y square. So let me put, there is nothing wrong, x square plus y square. So that's the circle. That's what you can expect. Of course, this bounding box, etc., you can get rid of. You can draw axis, etc., all these things. Now let us see how this graph will change as I change n. So instead of n equal to 2, if I say n equal to 3, oh, this has become like this, right? If I put n is equal to 4, this is how it looks like. For n is equal to 5, yes. So for odd and even, there is seem to be, for even there is this figure is closed. Of course, you can ask why. And for odd, so let us say if I put 50, yeah, this has become almost like a square. And if I say 52, sorry, 51, yeah, you can see now there is a clear-cut corner. Let us increase to 100. This is almost like a square. And what about 101? Right? Okay. Now if you want, let us say I want to add a circle to this. So there is an inbuilt function to create a circle. So I can say, let us say add circle circle, and no, I think I have to say centered at 0, 0 with radius 1. Yeah, you can see here, that's the circle. circle is added to this curve. Okay, right. So this is how you can define plot graph of a function which is defined by implicitly defined function. Similarly, if you can plot graph of function defined by parameters. So let us say I have this function. So x is given by t times sine 1 minus t square, y is given by t into cos t square, t varying between minus 2 pi and 2 pi, and I want to plot graph of this function. Okay, so how do I do that? Let me see. Okay. The way to do is, so you can use a function called parametric underscore plot, and then you have to give these coordinates in a list square bracket. So first coordinate is t into sine 1 minus t square, second coordinate is t into cos t square, and t varying between minus 2 pi and 2 pi. Color is red, thickness is 1.2, and let us see how it looks like. So t I have not defined as a variable, so you can see here it is giving error, so I need to declare t as a variable. Yeah, so this is how the graph looks like. Looks beautiful. Yeah, so you can change x coordinate, y coordinate, and see how the graph looks like. Okay, similarly, if you want to plot graph of, let us say, polar graph in polar coordinates, so let us say r is equal to 1 plus 2 cos 1.05 theta, and theta varying between 0 to 2 pi. R is equal to f theta is the let us say equation of a curve defined in polar coordinate. So how do I plot its graph? Let us see. So this is, again, we are declaring t as a variable. So there is an inbuilt function called polar underscore plot, and then you give the value of r, which is 1 plus 2 times cos 1.05 t, and this t is varying between 0 to 200 pi, and you can mention number of points plotted, because when it plots the graph, no, of course it plots this x coordinate, y coordinate, and the number of points, the plot points is more, then you will have the curve much better curve. So let us execute this and see. Yeah, so this is a beautiful polar curve, right? Of course you can try to change for example, instead of 1.05, let us say, if I say 1.25. Okay, this is less complicated than the previous one, so let me make it if I make it, for example, 5, you can see. Yeah, so you can explore. So let me go back. I think the first one looks much better. 0.5 it was. Yeah, so that's the how you can plot polar polar function, right? You can also plot let us say a region. So there is a region plot. Try to explore. You can give two regions and then plot its graph. You can also plot graphs which are side by side. Okay, so let us say we want to plot 4 graphs. So I can create 2 rows and 2 columns in which I can add. So let me just give you an example of function which is defined in a region. So let us say this is created by what is called graphics array. So let me say, so fx is a sine x, gx is sine 2x, hx is sine 4x, and then p1, the plot of graph of sine x, p2 is graph of cos x, sorry, sine 2x, p3 is graph of x coordinate. This is a parametric plot. First coordinate is sine x, second coordinate is sine 2x, and then p4 is first coordinate is sine x, second coordinate is sine 4x, and then we are creating a list L, which is p1, p2, p3, p4, and then use graphics underscore array, and then this list, and what is the this is the number of rows. Here we are mentioning number of rows is 1, sorry, 2, so it will be 2 rows and 2 columns, and let us plot this. So you can see here, the first one is graph of sine x, this is sine 2x, This is parametric plot. X coordinate is sine x, y coordinate is sine 2x. This is x coordinate is sine x, y coordinate is sine 2x. And so this third figure is also known as figure 8. Of course, it is slightly transformed one along x-axis, and this is what is called figure 8. Okay, so this is how you can plot many graphs together side by side. Either you can superimpose one graph to other, or you can plot them side by side. All such options are there, and actually many options are there. You can plot a polygon. So this is a polygon whose coordinates are -1 0 -1 0 -1 1 0 and 0 1. And you can see here this color is goldenrod. So if you want to see what are the colors available, so you can see there is a function called colors, and this, let me put it in a dictionary. I'll call this a sorted list. So sorted list of colors. So it will give you, let us see, I mean, there are so many colors available. You can go through this list. You can see here there must be about and almost 50-60 colors, or maybe 100. Okay, you can count. Actually, you can count what is the length of this. So there are 148 148 colors which are inbuilt, and all these colors you can make use of. Okay, so there are many other 2D plotting facilities. You can plot a point, you can plot a line, you can plot a set of points. You can also plot, you can add text to a given plot. So for example, let us say to this I want to add a text, or let me choose some other plot. Let us say here I want to add a text. So I'll call text as T, and T is text something. Let us say I'll just simply say beautiful. This is a text, and the coordinate, what should be the coordinate? Let us say x, I'll add at x equal to -4 and y equal to, let us say 4, and then let me say p plus t. So you can see here a text has been added called beautiful. So you can even add any expressions, LaTeX expressions, etc. All these things. So this is what we call annotation, right? So you can add anything. You can plot even arrow. Okay, so all these options are there. Now let us look at how to plot some 3D functions. Okay, so 3D plots. So let us say we want to plot graph of a function which is f of xy is equal to sine x plus y into cos x plus y. So like plot function, there is a plot 3D function for this. And again, you can go to Sage documentation, and you can see here there is an option called plot 3D. So if you click on this, you will see a plot 3D documentation, which will be again some 323 pages documentation, and you can go through. You can click at any place, and there are beautiful graphs, etc. All these things you can copy paste. All such facilities are there. So this is how you can learn on your own using these inbuilt documentations. Okay, so let us see. So this, we want to plot graph of this function, which is defined by fxy is equal to sine x plus y into cos x minus y. So we'll simply say plot 3D, and then f of x comma y, and you need to mention the domain of x. So x goes from, let us say, from -2 to 2, and y also goes from -2 to 2. Okay, and let us see how the graph looks like. Okay, beautiful. So this is how the graph looks like, and you can even rotate this graph. You can click on this and press the mouse or left key button, and then you can rotate, right? You can do it in various format. Let me so 3D plot, again I just said there are lots of 3D plot options available. So for example, you can plot this surface like this. You can plot graph defined by parametric form, defined in spherical coordinate, polar coordinate, in cylindrical coordinate, or function surface of revolution, and some of the inbuilt surfaces, objects, let us say sphere, planetonic solids. All such options are there. So for example, let me say, just for fun, I want to add a sphere to this. So I'll say sphere, and yeah, let me say, I don't know, color equal to, let us say, green. Yeah, so you can see here sphere has been added, the unit sphere at the center, and again you can rotate. Of course, you can change the color and then things like that. So various options are there, and in this plotting also you can change the color, you can change what is called mesh style, and all such options are there. And if you want to save this, you can right click and save this file. Now let us look at how we can define let us say, plot graph of function which is defined by, let us say, defined in parametric form. So let me, yeah, okay. So let us define. Yeah, so u is a variable, and the curve is given by the x coordinate is u, y coordinate is cos 4u, and z coordinate is u square. And then this is revolution plot 3D. So and then you are revolving this curve about, let us say, z axis, about z axis. And then when you click on this, this is how you can plot surface of a revolution of a curve. And you can see here, again, this you can rotate, so you can see the curve and the surface it generates when you rotate this about z axis. You can also rotate about x axis. For example, here, instead of z axis, if I say x axis, or let us say y axis, and then see what happens. You can see here now it doesn't look all that great, yeah, but still looks beautiful, right? If I say about x axis, you might not see anything. Yeah, no, not bad. Yeah, right. So z axis looks much better. So let us keep it. So it looks like a beautiful cup. Right. So this is, you can plot surface of revolution, or you can plot let us say, uh, suppose you want to do contour plot, or let us do implicit plot. First, let us do implicit plot. Again, let us try to explore the same function. We want to plot graph of function defined by, let us say, x to the power n plus y to the power n plus z to the power n for various values of n, right? So mm, let us see how we will do. Okay, so this is implicit plot. So we will define x, y, z as variables, and to begin with, let us say k is equal to 2, and implicit plot 3D, x to power k plus y to power k plus z to power k minus 4, and x varies between minus 2 to y varies between minus 2 and 2, z varies between minus 2 and 2. Color is light sea green, and number of points it plots is 100. So let us see. You would think that this will be of course a sphere, and that's what you can see here. That's a sphere. Now instead of 2, let us make it 3. Let us make it 3. Now what do you see? Okay, so now this is it's open. Now if you recall the graph, implicit graph, x square plus x cube plus y cube minus 1, you see that it is just a profile. That was a profile curve of this surface. So now let me say if I make it 20, then again you will see closed surface. It's almost like a cube, and instead of 20, if you make it 200, the corner will be sharp one. Yeah, you can see here these corners are sharp. But if I say 201, again it will be not a closed surface. Yeah, so see, now you can see here, right, the profile curve of x power 201 plus y power 201 minus 4 equal to 0, right? Okay, so that's a implicit plot and various options you can explore, right? Similarly, let us look at how you can plot contours. Let us say how you can plot contours. So let us say we will use the same function fxy which we defined, or let us use some other function. Okay, I already have inbuilt here. So this is a let us look at, we want to plot contours of this function y fxy is equal to, so let me just, for sake of completion, let me declare x and y as variables, fxy equal to this, and first let us plot graph of this surface, how this surface looks like. Okay, so the surface looks like this. You can see here lots of peaks and valleys. So there are so many local maxima, local minima, right? In this case, that's what you can expect. Now let us say let us see how you can, here also you can make, and let us say fig size equal to 4. So let me make it smaller, figure size. Okay, now let us see, you want to plot the contours. So what are the contours? Actually contours, you can project these level curves on xy plane. So if you take any z plane and intersect this surface by z plane, and then this will be a curve, that curve you project on xy plane, that is what is called contours. So you can see so we can plot this using a function called contour plot. And what contour plot of the function fxy, x varying between minus 2 pi and 2 pi, y varying between minus 2 pi and 2 pi here. Yeah, and then you can mention whether you want let me just plot with this by default. Okay, so you can see here the various shading comes for this. So there are so many local maxima, local minimum, and also saddle point. So that is what you can see. Now let us say if I want to remove this filling, the shading inside, or you want to increase the number of contours, then there is an option. So that option you can mention, this is fill equal to false, and contours, number of contours. So let me make it 20, so that many more will come. Let me plot it separately, so both these things will be there. So this we want 20. Okay, so now you can see here these shadings have disappeared and there are many more contours. Okay, in fact you can even ask it to print at what label these contours are plotted, label curves are plotted. So let us take help on contour plot, contour plot question mark, and see how it can be done. So you can see here the options. In the options, there are fill, CMap, contours, width, labels. Okay, so labels we will say equal to true. Let us see. Okay, so we'll say labels equal to true. Sorry, spelling mistake. True. Yeah, that's correct. So you can see here, for example, if I look at this curve is z is equal to 2. This is intersection of the surface with z equal to the plane z equal to 2. Okay, right? So this is how you can plot I mean many 3D objects. And of course, as I said, some of the standard objects also it plots. For example, if I want to plot tetrahedron, or let us say I want to plot a cube, so you can simply say cube. Yeah, you'll get a cube, right? Again, you can rotate. Suppose if I want icosahedron, yeah, you'll get an icosahedron. You see here, right? Or if I want a tetrahedron, it gives you a tetrahedron 3D figure, right? If you want to, let us say, dodecahedron, that also is there. So all these, the planetonic solids, there are inbuilt function to plot all these things, and many other things. Let me at the end, let me explain this. Many times you can also, as I said in my introduction last time, you can even have some kind of interactive plot. You can create an animations and see various changes, the parameters. You change some parameter and see how the graph changes, etc. All these things can be done. So you can define control like drop down menu or sliders. All such options are available. So let us look at one such. Suppose we want to plot graph of a function, let us say sine kx, and we want to see how the graph changes as we change k. So, graph of sine kx, how does it change when we change k? I mean, this is simple curve. So how does one do that? So there is an option called uh, at the rate interact, which means interactive plot. So you say interact, and then here this def, I'll do this later also in the maybe coming classes, how to define functions, user defined functions. But here it's not giving any name, so underscore, and it is giving the value, the k varies from 1 to 10, and the default value is 1. And then a is the beginning, the beginning of the, I mean the domain on which it wants to plot is a to b. A is the beginning, so it is defined in input box, and starts default value is 0. B is input box, default value is 1, and then p is equal to plot sine kx from a to b. And let us just print that it is a graph of sine kx, and then show this. So this instead of just printing p, you can say show this graph. So this show is also an option. Let me in this. Okay, so you can see here it has created a at present graph of sine x between 0 to 1 by default. So let us choose, I'll choose a is equal to minus 2 pi, and b is also equal to 2 pi. So now this graph has automatically changed from minus 2 pi to 2 pi. And let us now change k. Suppose the k is a slider. That is how you can see here. This k is a slider. It varies from 1 to 10. You can change here. And so let us say if I change this, you can see here the graph is automatically changing. If the k increases, you can see, right? And you can put various other, for example, if I want to make it let us say I'll put one more slider. Let us say instead of k, let me put let us say capital A, goes from, let us say, minus 2 to okay, minus 5 to 5. And so I'll multiply this by capital A star, right? Let us see. Now you can see here k is also varying, a is also varying. So let me again put it minus 2 star pi to 2 star pi, and let us say k is this, k is 5, and a is, let us say, this. Okay, so you can see here now the height of this graph is increasing or decreasing depending upon what is a. Of course, you can explore with some other functions and see. So you could try to explore more and interact, this way you can create an interactive plot. You can even create drop down menu or sliders or checkbox for various options of the graph, etc. You can have more than one graphs, etc. So this is very useful option. Of course it requires little more experience. So as you become experienced, and especially if you are teaching some course, etc., this kind of thing will be very useful. It will bring a lot of interactivity in the class. Okay, so I think that's all. I'll share this worksheet, and I will also give you set of assignments that will be uploaded only in app. So in case some of your friends who have not registered yet, and if they want to make use of this worksheet, the assignments and the solutions, etc., you can ask them to register. And also please try to register in Telegram, because that is where many messages, etc., are coming. Many people are uh, giving their problems. I mean, some of the problems that they are facing, I'm trying to resolve as much as I can do. Uh, uh, so, uh, uh, so okay. So once again, in case you want to save this file, you can save it in various format. I can download in terms of let us say as a LaTeX, as a PDF file. So it will go in my drop download directory. Yeah, so already see, you can see here this. I can open the folder, and this is where it is. So all these entire things are already there, and this is what I will share with you all. Okay, so thank you very much. I'll see you on uh, coming Wednesday again at 3:30. So I hope all of you enjoyed this lecture, and try to explore these two documents, and try to explore many more plots. Okay.